So today's lecture, it is like this. Let us start with the major emissions and how to control emissions from SI engine. Okay. The various methods to control emissions from SI engines are, there are basically two different methods available. The main mechanism or the device that is used to control the emission from the SI engine is the catalytic converter, right? And followed by that, we also have a method to reduce the presence of NOx in the engine exhaust. That can be done using this exhaust gas recirculation, right? Using exhaust gas recirculation, we can control the NOx emission. Okay, only NOx you can control here. Whereas in the case of catalytic converter, you can control unburned hydrocarbon, you can control CO, you can control the emission of NOx. All the three can be controlled. Okay, so this is what we are going to discuss today. So we have discussed already the major emissions from the IC engines. It can be SI engine or CE engine. The three major emissions are unburned hydrocarbons, oxides of carbon, especially this carbon monoxide. Right? We cannot prevent CO2. Right? This is harmful, so this has to be avoided. Emission of CO2 has to be avoided from the IC engines, and the oxides of nitrogen. Okay, so this is what, these are the emissions, harmful emissions that are present in the engine exhaust, right? Now to control this, why do you want to control, right? Or how this has evolved, the control mechanism to reduce the harmful emissions from the engine exhaust. The reason is that we started, the transportation sector started to grow very rapidly, especially in India, and we are the fourth largest manufacturer of car in the world, according up to 2019 statistics, right? And India is the largest manufacturer of tractors, not only in the urban area, in the rural area also. In the rural area, especially for agriculture sector, we are using this tractors. Tractors will not come under automobile sector; it comes under agriculture sector, but still it uses IC engines, right? Through that also emissions are going to be there. So the emission is going to be there both in the rural as well as in the urban area, but predominantly in the urban area. So we cannot say that there is no emission or pollution in the rural area, right? So for agriculture purpose, we are using tractors. And if you see the total amount of sales in India of motor vehicles during the financial year 2018-19, right? Here you can see this is the data, right? Almost 3.38 millions of passenger vehicles were sold, and 1.01 million of commercial vehicles were sold, and three wheelers around 7 lakh. Three wheelers, your auto rickshaws were sold, and two wheelers 21.18 million two wheelers were sold. This is during the financial year 2018-19, correct? So that means these many vehicles are coming out, are being sold, and they are playing on the road, right? When these vehicles are going to operate, it is going to emit lot of emissions, right? That is the problem, right? Especially in the case of Delhi, where we have the huge amount of air pollution, right? If you compare the statistics of the number of vehicles that are available in Delhi roads, right? In during 2008, it was only 56 lakhs of vehicles were there in Delhi, and in 2018, over a period of 10 years, right? So now the amount of vehicles plying on the roads of Delhi is 1.0109 crore. Okay, so almost double, right? From 0.56 crore or 56 lakhs, it has come to more than 1 lakh at 2018. Okay, over a period of 10 years, right? So because of this huge traffic or more amount of automobiles that are being used, this leads to, what are the problems that we are going to face? This leads to the traffic jam, right? Apart from this, it is going to degrade the environment, and other health hazards for the human beings are going to be there because of the pollution. Because these automobiles are the exhaust from the engine, it is harmful, right? So during this combustion inside the engine, how does this combustion occurs? Or the chemical reaction that is involved in the combustion process is, when the fuel and air they react, it gives out CO2, water vapor, and more amount of heat, right? This is the useful heat which is converted into work, and thereby the vehicle is going to fly. or it is going to move, right? So apart from this heat, we want this heat, right? Apart from this heat, it gives out other byproducts like CO2, water vapor, and the other harmful emissions also, which are nothing but the hydrocarbon, unburned hydrocarbon, carbon monoxide, and NOx. So these three we call it as the harmful emissions, right? Why these harmful emissions are coming? Because we cannot have complete combustion, right? This combustion, whatever the method we adopt, we cannot claim that 100% complete combustion is possible. Only when you are going to have 100% complete combustion, you can say that these harmful gases, especially this CO, right, we can prevent, but that is not possible. 100% complete combustion is not possible. As a result, we are going to have the unburned hydrocarbon, carbon monoxide, and NOx are available in the engine exhaust. Okay, so now how to reduce? Okay, now we come to know that you cannot have 100% complete combustion. That means the harmful emissions from the engine cannot be prevented. But now I don't want to let this into the atmosphere, but I want to do some process. Thereby, I want to reduce the harmfulness of the products of combustion from the engine exhaust. Okay. So now how to achieve this? For this, we have a device called catalytic converter, right? So this is not a new device. We started using this device over a long time period, but over a period of time, what happened? We have improved the efficiency of the catalytic converter, right? So basically, this catalytic converter, this is how it appears. This will be provided in the exhaust manifold of the engine, right? We used to place the engine exhaust is allowed to enter into this. The harmful emissions that are present in the engine exhaust, especially the unburned hydrocarbon, carbon monoxide, and NOx, when it enters into the catalytic converter and it leaves the catalytic converter, it is the harmfulness is going to be brought down. That means your carbon monoxide will become carbon dioxide, and your NOx, right? Let us say NO, that will become N and O2, right? Nitrogen and oxygen, right? And the unburned hydrocarbon, it will become CO2 and water vapor, right? So we will convert this completely into unharmful emissions from the engine, right? So basically, this catalytic converter is a device for treating the engine exhaust, right? Thereby, the harmful emissions are going to be converted into unharmful emissions. And for this, to convert this harmful emission into unharmful emission, we are going to have some reactions, right, inside the catalytic converter, right? So this catalytic converter was first patented by Eugene Houdry in 1956. He is from France, right? He is a well-known automobile engineer, a mechanical engineer. He devised this catalytic converter to reduce the harmful emissions from the engine exhaust. So this is Eugene Houdry, and this catalytic converter is placed in between the exhaust manifold and the tailpipe. So if you see this diagram, this is the exhaust pipeline from a two-wheeler, right? So this is the engine exhaust. This is the exhaust manifold, right? And this is the tailpipe. So in between the exhaust manifold and the tailpipe, we have provided the catalytic converter. Exhaust manifold and tailpipe. Between the exhaust manifold and tailpipe, catalytic converter is placed or located in order to control the harmful emissions. Now coming to if you get into the catalytic converter, what does this catalytic converter contains? It has three major components, or we can say four, because if you are going to consider the covering, right, the casing of the catalytic converter, then we are having four major components. The first one we call it as the substrate, right? And this substrate, we have a substrate, and then we have a wash coat, then we will have a catalyst, or many catalysts are going to be there. These are the three major components. Apart from that, we are going to have a outer casing to cover the entire catalytic converter, right? The first main component is a substrate. This substrate is nothing but it is made up of alumina. Alumina is a well-known ceramic material, right? So alumina is a well-known ceramic material. This ceramic material, we are going to place it inside the a casing, right? And this is placed in between the exhaust manifold and the tailpipe. This ceramic material, it is going to be in the form of a honeycomb structure, right? it is this alumina is made up in the form of a honeycomb structure. The reason for having this honeycomb structure is that this will increase the surface area, thereby the chemical reaction will be done properly. Right? In order to have more surface area and to have better chemical reaction, we are providing this substrate in the form of a honeycomb structure. And over this honeycomb structure, this substrate, right, or alumina, we are going to have aluminum material, right? A layer of aluminum material is going to be there, that we call it as a wash coat. And in that wash coat, we are going to have randomly some catalyst, which is nothing but a metal, right? Here and there you will find the presence of catalyst, namely it can be the catalyst can be platinum, palladium, rhodium, cerium, right? So it is going to be there over the wash coat, right? So basically we are going to have substrate is the base layer. Over the base layer we are going to have wash coat, and in the wash coat layer we are going to have presence of catalyst. This catalyst are platinum, palladium, rhodium, cerium. So these metals are going to be there, right? So basically this catalytic converter, it does two operations. So one we call it as a reduction process, reduction chemical process, and the second one is called as the oxidation process, right? So these catalysts are going to enhance this process. Okay, the presence of catalyst is going to enhance the process. Okay, and as I told you that we are going to have two stages of chemical reaction inside the catalytic converter. One we call it as the reduction process, right? The reaction inside the catalytic converter, the stage 1 reaction is reduction reaction, then followed by we are going to have stage 2 reaction, which is nothing but the oxidation reaction. And for the reduction reaction to occur, these catalysts are necessary. Platinum and rhodium, these two catalysts are responsible for the reduction reaction, which is going to be the stage 1 reaction of the catalytic converter. Followed by the stage 1 reaction, we are going to have stage 2 reaction. In the case of stage 2 reaction, materials like platinum, palladium and cerium, so these are responsible for the oxidation reaction. Platinum and rhodium are responsible for reduction reaction. Platinum and palladium, in some cases we also go for cerium. So these are responsible for the oxidation reaction. Okay. So now I have told you, in the case of catalytic converter, we are going to have a base substrate which is made up of ceramic material, and the alumina is the well-known ceramic material that is used in the catalytic converter. And over the base material or the base substrate, we are going to have the wash coat, which is the aluminum. Okay, and in the wash coat we are going to have the presence of catalyst. So this is the presence of catalyst, this red dot, right? So we are going to have the honeycomb structure of the substrate. This is the honeycomb structure, one particular honeycomb structure, one region we have considered. Okay, and from there, if you see the layer over the substrate is the wash coat, and in the wash coat we are going to have the catalyst. So these catalysts are responsible for the chemical reactions, thereby the harmful emissions from the engine exhaust are going to be converted into unharmful emissions. Now let us see how does this catalytic converter works, the operation of the catalytic converter, right? So that let us see. So the chemical reaction that takes place inside the catalytic converter, it takes place in two stages. Stage 1 we call it as a reduction stage. Reduction means removal of oxygen is what we call it as reduction process. So now the first stage, in the first stage of the catalytic converter, in the first stage of the chemical reaction that takes place in the catalytic converter, the catalyst like platinum and rhodium, right? Platinum and rhodium are responsible for this reduction process, right? When the NOx, let us say NO, that is present in the engine exhaust, when it enters into the catalytic converter, especially the reduction stage, where the catalyst platinum and rhodium are available, when it comes in contact with this catalytic converter, when the oxidation reaction takes place. During this oxidation reaction, the oxygen that is present with the nitrogen, right, in the case of NOx, the oxygen that is present in the Normally for combustion, we are going to supply nitrogen. We are going to supply air. The air contains nitrogen, and at high temperature, this nitrogen gets dissociated. The diatomic nitrogen N2 gets dissociated into monoatomic nitrogen, that is N, which is reactive and reacts with the oxygen that is available in the air. Thereby, NOx is formed in the engine cylinder. Now it is coming out along with the products of combustion or along with the engine exhaust. When it enters into the catalytic converter, now we are going to reduce this. NO is going to get reduced, right? This reduction reaction is going to take place. Thereby, we are going to remove the oxygen that is associated with the NOx, right? So when it comes in contact with the catalytic converter, where this platinum and rhodium are there, it gets converted into N2 and O2. It gets converted into, the chemical reaction is oxidation reduction reaction. Thereby, the oxygen is removed from there, so it will become O2 and N2. Right. So the harmful NOx or the harmful oxides of nitrogen is reduced during this reaction, and we are going to get unharmful nitrogen and oxygen. So that is going to leave through the exhaust, right, after it comes out from the catalytic converter. Now the second stage of the catalytic converter reaction, right? So now we have discussed about the NOx. The other emissions are hydrocarbon and other the CO, right? Carbon monoxide. These are the other two emissions, right? So the second stage of the catalytic converter, the second reaction in the catalytic converter is the oxidation reaction. Okay. So now from the previous stage, right, when in the reduction stage, from the oxides of nitrogen, we have removed the oxygen, right? This oxygen is available, and also some of the oxygen that is present in the air or in the exhaust gas, which has not reacted with the hydrocarbon, right? So that oxygen, the oxygen that is available in the air as it comes out through the exhaust gas, and also the oxygen that are formed during the reduction process of the previous stage of the reaction. So those oxygens are available in the catalytic converter. Now to this catalytic converter, when the carbon monoxide that is present in the engine exhaust, when it comes in contact with this oxygen, so oxygen is available. Now from the exhaust from the engine, the presence of carbon monoxide, when it comes in contact with the oxygen that is available, this carbon monoxide will become CO2, right? So it is going to leave as CO2. CO2 is not that harmful when compared to CO. CO is a, carbon monoxide is a poisonous gas. Okay. So in the exhaust, we are going to have CO2, the poisonous or the harmful carbon monoxide that is present in the engine exhaust. When it comes in contact with the oxygen, it is going to undergo oxidation process. Thereby CO becomes CO2, and it is going to leave. Finally it is going to leave the catalytic converter as unharmful emission from the engine. Okay. So this is second stage reaction. So now one more harmful emission is there, right? That is unburned hydrocarbon. Okay, that unburned hydrocarbon also, it is going to undergo oxidation. So in the stage 2, in the second stage of the catalytic converter reaction, we are going to have oxidation. So in the oxidation process, carbon monoxide has become carbon dioxide initially, and the unburned hydrocarbon that is present in the engine exhaust, the unburned hydrocarbon that is present in the engine exhaust, when it comes in contact with the oxygen, so this hydrogen will react with oxygen, and it is going to form H2O. This hydrogen that is present in the engine exhaust, or the present in the hydrocarbon, that is going to react with the oxygen, and it is going to form H2O. And the carbon, right, from the unburned hydrocarbon, that is going to react with this, and it is going to form CO2. Okay. So in the second stage, we are going to have oxidation. Oxidation of carbon monoxide will become carbon dioxide, and oxidation of unburned hydrocarbon, that will lead to formation of water vapor and carbon dioxide, CO2. Okay. So this water vapor, carbon dioxide, and in the first stage of the reaction, the reduction process, we are going to have only nitrogen, right? So these are going to be led to the surrounding, which is not considered as harmful, right? Which is not harmful for the human beings. Okay. So this is the reaction that is taking place inside the catalytic converter, right? Now, coming to the catalytic converter operation, normally we want to have better efficiency of any system. In engineering, we prefer the system which performs well. Right? Similarly, for the catalytic converter also, we want to have the catalytic converter to operate with higher efficiency. Okay. For the catalytic converter to operate at a higher efficiency, it requires certain temperature. At a certain temperature only, it can perform well. If the temperature is too less, then the conversion efficiency of the harmful emission into unharmful emission, that is not going to be having higher efficiency. This conversion efficiency will be less if the temperature of the catalytic converter is less. Okay. So the minimum temperature that is required to carry out this reaction or to activate the catalytic converter, right? So that minimum temperature is something around 250 to 300 degrees C. If the catalytic converter is held at a temperature of 250 to 300 degrees C, then the conversion efficiency is going to be more than 50%. Right? If the temperature is less, then the conversion efficiency is going to be less. That means we say that the catalytic converter is not performing well. So the temperature at which it performs well or the conversion efficiency is more than 50%, that temperature we call it as light of temperature. That temperature we call it as light of temperature. That means the catalytic converter should be allowed to operate with this light of temperature or at a temperature higher than the light of temperature. Only then it can perform well, and thereby we can have unharmful emissions from the engine exhaust. Okay. So the time period during which the catalytic converter is active, right? The time period during which the catalytic converter is active is what we call it as the light of time, right? And the temperature at which the catalytic converter is going to perform well is called light of temperature, right? So we have light of time and the light of temperature, light of time and light of temperature. So the harmful emissions, when will you have these harmful emissions? Let us say you have provided the catalytic converter in the exhaust pipeline of the engine, right? So in between the exhaust manifold and the tailpipe, we are provided the catalytic converter, correct? And when the engine is going to operate at different operating conditions, right? When we are going to start the engine during cold start of the engine, right? The temperature is not going to be higher. If the temperature is not going to be higher, if the temperature is going to be less than the light of temperature, then the emissions that are going to come out from the tailpipe is going to be harmful because your catalytic converter is not operating with higher efficiency, right? And let us say if you are going to have the automobile and you are going to ride for a short distance, not for a longer distance, right? When you are going to drive to a short distance or during the short trip, the temperature is not going to be higher and your catalytic converter will not perform well. And during that condition also, you will have the harmful emissions from the engine. Okay. So now how to overcome this, right? See, we are having harmful emissions from the engine after combustion. So to reduce the harmful emissions, we have gone for the catalytic converter. Even after providing the catalytic converter under certain engine operating conditions, it is not performing well. Catalytic converter is not performing well. So what they have done is that they have come out with a mechanism, right? So in some of the vehicles, they have provided with electrical heater. This catalytic converter will be, let us say you are going to have a cold start of the engine, right? During the cold start, this electric heater also will start. So it will, you are going to have a electrical coil, heating coil over the catalytic converter. Thereby the temperature of the catalytic converter is going to be brought higher. So at a higher temperature, the performance of the catalytic converter is going to be more. Thereby the harmful emissions coming out from the engine are going to be prevented. Okay, so we have to provide, or in some of the vehicles, the electrical heaters are provided, or the electrical heating coils are provided over the catalytic converter. Thereby the temperature of the catalytic converter is brought higher, or the temperature is going to be more than the light of temperature. Thereby the reaction or the conversion of your harmful gases into unharmful gases emissions is going to be happening. Okay. So the other methods to achieve this, to improve the efficiency of the conversion efficiency of the catalytic converter is that if you are going to place the catalytic converter closer to the engine, then the temperature of the catalytic converter is going to be higher. At higher temperature is going to perform well. Okay. And similarly, to prevent the loss of heat from the catalytic converter, we can provide insulation, right? So when you are going to have better insulation, the heat transfer from the catalytic converter to the surrounding is going to be less, and the temperature of the catalytic converter is going to be maintained at a temperature above the light of temperature. Okay, so thereby the conversion efficiency is going to be higher. So in general, when the engine is going to operate at normal operation, right, during normal operating mode, the conversion efficiency of the catalytic converter are going to be higher because the temperature is more than the light of temperature. You will find a conversion efficiency for it prevents almost 98% of the carbon monoxide into carbon dioxide, and the NOx also, right? It is getting reduced. This NOx is going to get converted into nitrogen and oxygen. 95% of the conversion is possible. And similarly for the unburned hydrocarbon, it is going to become water vapor and CO2, and the conversion efficiency is around 95%. So you will find more than 95% of conversion efficiency when the engine is going to operate under normal operating mode. Okay. So now this, how long this we can use this catalytic converter? All right, you are having an automobile, and the automobile is going to operate. We are going to use it for transportation purpose. How long this catalytic converter is going to perform well? Right? Then there is a thumb rule. We say that over a period of 2 lakh kilometers, the catalytic converter will perform well. If you are going to operate the vehicle beyond 2 lakh kilometers, then you have to replace the catalytic converter. Right? This is a thumb rule. Right? Not only this, the performance of the catalytic converter also comes down by two reasons. One is by thermal degradation, other one is by the chemical degradation. Thermal degradation is that I have told you that if the temperature is less than the light of temperature, then the performance is going to come down. Similarly, if the temperature is going to be more than 800 Kelvin, right? If the catalytic converter temperature is brought above 800 Kelvin, there also its performance is going to come down. So that we call it as thermal degradation of the catalytic converter. So between this 250 degrees C to this 800 Kelvin, right? This 800 Kelvin, your catalytic converter performs well, right? And similarly, in the exhaust, if you are going to have the presence of lube oil, right, and the presence of lead or presence of sulfur, so these will lead to the poor efficiency of the catalytic converter. That we call it as the chemical degradation of the catalytic converter. If you are going to have presence of lube oil in the engine exhaust, or presence of lead in the engine exhaust, or presence of sulfur in the engine exhaust, that will lead to chemical degradation of the catalytic converter. Okay. So now I am using a catalytic converter to prevent the harmful emissions from the engine. Okay. So how do you know that your catalytic converter is performing well? So for that, what they are doing is that they will provide oxygen sensors, right? So oxygen sensors are provided both before and after the catalytic converter. So this is an engine. To this engine, this is the intake manifold where the fuel is supplied along with air. This is a fuel injector, and air is entering through the intake manifold, and through the intake valve it is going to enter into the engine cylinder, and as soon as the spark is introduced by the spark plug, combustion takes place, and during the exhaust stroke, the exhaust valve opens, and the products of combustion or the engine exhaust is going to leave through the exhaust manifold, and then it is going to pass through the catalytic converter, and it is going to leave through the tailpipe, finally led to the atmosphere. Now I am going to measure the presence of oxygen, right, in the exhaust, right, before and after the catalytic converter. If same amount of oxygen is available before and after, that means what? The oxidation process is not happening, or the catalytic converter is not working well, right? So normally what will happen if the oxidation process is going to be there, the amount of oxygen after the catalytic converter, the presence of oxygen after the catalytic converter is going to be less than the presence of oxygen before the catalytic converter. That means your catalytic converter is operating well. If this is not functioning well, then you will get same amount of oxygen present before and after the catalytic converter. So that will tell you the functioning of the catalytic converter. So this is sensed by the engine control unit, and it is going to give an alarm to replace the catalytic converter. Okay. So this is the method to determine whether the catalytic converter is functioning properly or not. Okay. This catalytic converter, I have told you that it is going to have three materials or three layers. So initially you are going to have a base substrate, followed by that we are going to have the wash coat, and in the wash coat we are going to have the catalyst, right? The platinum, palladium, rhodium, these are the catalysts that are going to be present, right? So basically we have two different types of design of the catalytic converter. One we call it as the monolith design, right, where we are going to have the honeycomb structure, and other one is called the pelletized sphere, there are two designs that are available for the catalytic converter. One we call it as a monolith design, and the other one we call it as a pelletized sphere. Among these two, monolith design is widely used, right? Compared to the pelletized sphere, the monolith design is widely used, and because this provides the higher surface area, and we are going to have a very good conversion efficiency, right? If you see the honeycomb structure, you will be having this cells of the cross section, right, of 1 mm by 1 mm is going to be there. So if you are going to measure in an area of 1 centimeter by 1 centimeter, in that area almost maximum you can accommodate 100 cells, right? 1 mm by 1 mm you can accommodate 100, because it is going to have 10 by 10. So 100 cells maximum is possible. So 30 to 100 is possible. Okay, and to calculate the conversion efficiency, right? Let us say, for example, I want to consider the unburned hydrocarbon, right? That is coming out from the engine, and after the catalytic converter, how much amount of hydrocarbon is going to be available. So this is the inlet to the catalytic converter, and this is the outlet from the catalytic converter. So now take the case of the unburned hydrocarbon emission that is present in the engine exhaust, right? So this mass flow rate of the hydrocarbon that is present at the entry of the catalytic converter minus the mass flow rate of the hydrocarbon that is leaving the catalytic converter, right? Now let us say, for example, 100 quantities of unburned hydrocarbon is entering, right? And only 5 is leaving. 100 is entering, 5 is leaving, divided by 100. So that will give you 95%. This is the conversion efficiency. Okay, this is how the conversion efficiency is calculated. Okay, and there are two designs that are available in the case of the catalytic converter. One we have told that monolith design, and the other one is the pelletized spheres, right? So instead of the honeycomb structure, you can have pellets of spheres, right, of this ceramic material. Okay, so in between the pellets, the flue gas has to pass through, right? So this is another design, but this is not used widely. We use only that monolith design where the honeycomb structure is there. Coming to the conversion efficiency, the conversion efficiency of the catalytic converter, it depends upon two parameters, right? One, it depends upon the temperature, which I have told you, the light of temperature, right? The temperature above 250 degrees C to 300 degrees C, we call it as the light of temperature, where the conversion efficiency is more than 50%. Okay, so now if you see for the emissions like carbon monoxide and hydrocarbon, right? So if the temperature, you can see here, if the temperature is around 300 degrees C, right? See, if the temperature is less, the conversion efficiency is also less. As the temperature increases, the conversion efficiency increases, and around 300 degrees C, more than 300 degrees C, the conversion efficiency of the hydrocarbon into water vapor and CO2 is around 60%. Conversion of hydrocarbon into water vapor and CO2, that conversion efficiency is almost 60%. Okay, so it depends upon the temperature. This is what we call the light of temperature. Now coming to the carbon monoxide, the harmful emission carbon monoxide, as the temperature of the catalytic converter increases, the conversion efficiency for carbon monoxide is also going to increase, and it reaches a peak, and after that it is going to be almost constant, right? So the efficiency of, let us say, something around 95% is possible beyond temperature of 300 degrees C. Okay, so it depends upon temperature. This is one point. And the second point is that the conversion efficiency of the catalytic converter, it also depends upon the equivalence ratio or the air fuel ratio. And they have observed that for all the three major emissions like carbon monoxide, unburned hydrocarbon, and NOx, right? The conversion efficiency increases with the air fuel ratio as it increases and it approaches towards the stoichiometric condition, right? So from the rich side, right? If you move towards the lean side, from the rich, when you are going to move towards the lean side, the conversion efficiency is increasing for carbon monoxide and for hydrocarbon, right? And the maximum conversion efficiency is obtained within the region of air fuel ratio of 14.5 to 14.6. That means close to your stoichiometric condition. But this trend is not applicable for the NOx emission. For the NOx emission, it increases along with the when we move towards the lean side from the rich side, and the conversion efficiency is maximum at the closer to the stoichiometric condition. Beyond that, when we move towards the lean side, the conversion efficiency decreases drastically. Conversion efficiency decreases drastically. So for all the three emissions, if you see, the optimum range to operate is with air fuel ratio of 14.5 to 14.6. 14.6 is the stoichiometric air fuel ratio. Okay. So this is with reference to the air fuel ratio or with reference to the equivalence ratio, right, of the catalytic converter, right. So this is about catalytic converter. So catalytic converter is a device which is used to convert or to make the harmful emissions into unharmful emissions. There are three major emissions are there. One is NOx, other one is unbound hydrocarbon, and the third one is carbon monoxide. Now let us say if you are going to remove all the three using a catalytic converter, then that catalytic converter is what we call it as a three-way catalytic converter, right? This we call it as three-way catalytic converter. Let us say we are going to remove only the unbound hydrocarbon and carbon monoxide. Then this catalytic converter is called as two-way catalytic converter. Okay. So if you are going to use two-way catalytic converter, that means we are not going to remove the NOx, right? So if you want to concentrate with the removing the NOx, then the other method is available to remove the NOx from the engine exhaust, right? So that we call it as exhaust gas recirculation. In the case of exhaust gas recirculation, what we are trying to do is that part of the exhaust gas that is leaving through the tailpipe, so that is going to be brought and it is going to be provided as an input in the intake manifold. Okay. So thereby what we are trying to do, where does the NOx is going to be formed? The NOx is going to be formed inside the engine cylinder where the temperature is higher. If the combustion temperature is high within the engine cylinder, then the formation of NOx is going to be there. That means we have to bring down the combustion temperature. To bring down the combustion temperature inside the engine cylinder, what we are trying to do, we are going to dilute the gas that is entering, right? The air fuel mixture that is entering, we are going to dilute that. So we require a diluent, right, to dilute the air fuel mixture. So that diluent should not react. It should not be reacting. Such a diluent we have to use. So what we are trying to do is that this diluent is nothing but from the exhaust gases, we are going to use the nitrogen, carbon monoxide. These two are the major diluents, right? And the water vapor. So it contains, after the catalytic converter, we are going to have the nitrogen, carbon dioxide, and the water vapor. So this we are going to allow it into the intake manifold, right? So when you allow this into the intake manifold, the carbon dioxide, this is a triatomic because this is two atoms of oxygen and one atom of carbon is available. Whereas in the case of water vapor, we are having two atoms of hydrogen and one atom of oxygen is available. So this is a triatomic gas. This triatomic gas has higher specific heat. Specific heat is nothing but the amount of heat that is required to increase the temperature of the object by unit degree C. Right? What is the amount of heat that is required? So higher the specific heat, the temperature of the object is not going to increase suddenly. Right? So these triatomic gases, they have higher specific heat. That means it will take more amount of heat and thereby slowly its temperature is going to increase. Okay. So now we are going to allow these triatomic gases to enter into the intake manifold. Then it is going to bring down the change in the temperature during combustion. Right. The delta T it is going to bring down. Right. So this exhaust gas recirculation we can do by two ways. One is by external means and other one is by the internal means. Right. Mostly we will be having the external means. That means the exhaust gas recirculation will be provided after your catalytic converter, and the part of the exhaust gas is going to be allowed into the intake manifold from the exhaust, right? So we are going to have a part of the exhaust gas being extracted, and it is going to be cooled and then introduced back into the intake manifold, right? The other option is that you can control if you are very particular about controlling the NOx emission, right? You are ready to sacrifice the engine performance, right? If that is the case, then what we can do, we can change the valve opening and closing time, right? So if you are going to if you are going to close the exhaust valve quickly or early, right? That means what? The complete removal of exhaust gas is not done. during the exhaust stroke, the products of combustion or the exhaust gases from the engine has to leave, and it has to be sent to the surrounding, right? If you are going to close the valve quickly, that means a certain amount of gas is going to, exhaust gas is going to remain within the engine cylinder, and thereby when you are going to allow the fresh charge to enter during the intake stroke, because of the presence of the exhaust gas, the dilution of the gas is going to happen, and thereby the temperature we can bring down, right? But remember, the engine performance will come down. And the other option is that we can delay, right, the opening of the intake valve. If you are going to delay the opening of the intake valve, then what will happen? The amount of fuel air mixture that is going to enter is going to be less, right? Thereby we are going to make the dilution inside the combustion chamber, and the temperature of the combustion chamber can be brought down, right? So remember, because of this, internally if you are going to have this exhaust gas recirculation or presence of the residual exhaust gases, then that will also lead to dilution, and that will lead to the reduction in the NOx. But remember, the performance of the engine will come down, right? And also because of the reduced temperature, we can have misfire also, and the as a result of this, you can have the increased presence of hydrocarbon, unburned hydrocarbon, and more amount of soot if it is going to be CI engine. Okay, so normally to the maximum we will go for 50% of the recirculation of exhaust gas, or less than the 50%. So this amount of exhaust gas that is entering into the intake manifold, that is regulated using an exhaust gas recirculation valve, right? So that schematic diagram I will show you now. So this is the intake manifold, right, of SI engine, right? Assume that we are going to have port fuel injection or manifold injection. So fuel is injected here, so air is entering here. Both air and fuel, it is going to undergo mixing. So pre-mixed air fuel mixture is allowed into the engine cylinder, and combustion takes place. After combustion, the products of combustion are going to leave through the exhaust manifold. A part of the exhaust gas is sent back to the intake manifold by operating a exhaust gas recirculation valve. So thereby the NOx emission can be controlled.